Hi, Unix Chapter 2 and Part 1. So in this particular series of videos about Chapter 2, we're going to talk about file systems and how to look at the directories and those sorts of things. And I'm going to try this a little bit differently. I'm not going to run the screen show or the slideshow as such, but I am going to just click on the slides from within the presentation. So most of you are pretty familiar with all of this, so let me be brief. The within the Unix and Linux file systems, just like in NTFS or FAT or Windows, file is a basic component for data storage. The file system is the way of organizing files on devices. So regarding numbers of sectors, sector sizes, all of those pieces, files can be saved more efficiently, or the file structure can be set up so that the drive can run more efficiently. UFS, as we see here, UFS is the original native Unix file system. Okay, so, and I have some additional information, but it's expandable, supports large amounts of storage, and provides for excellent security and reliability. In Part 3, I think we look at the specific security pieces. In Linux, a native system is called EXT, so Extended File System. So, you know, what do we see as a user or as an administrator, whether it be Unix or Linux? And you know, really, either one, it's transparent to us as a user or as an administrator for the most part. But EXT is the default file system for Linux. It looks like UFS, and newer versions go up to ext4. Now the root hierarchy. So within every version of Linux or Unix, there's sort of the same sort of structure. Now files and configuration files within that structure can vary a whole lot. But overall, the same structure is the same throughout Linux or Unix, or even various versions of Linux, such as Red Hat or Ubuntu. So the root, and that's designated by that / file system, is mounted by the kernel when the system starts. Now, there's a root hierarchy. Don't confuse that with the root as the administrator. There's also a root when you discuss, or in the context of users, root is the administrator. Okay, and the root, as far as file structure is concerned, is that top level directory. Now, the root file system contains all essential programs for file system repair. Okay, so restoring from backup, starting the system, initializing all devices and operating resources, and information for mounting other file systems. Within that directory, there is bin, that contains binaries and executables, and the boot, which contains the files needed for the bootstrap loader, and that's the utility that starts the OS and has the kernel image files. Now let me go to, I've logged into Linux, okay, and if we can just get an idea, notice that I'm working on two screens, so I'll bounce back and forth. So that / directory, that means the root, and then home is a folder or directory below that, and then all of us users are below that. So if we change directory, CD is how you change directories. CD, and if I just go a dot, 2 dots, CD space dot dot, and then you see how that goes up one directory. CD space dot dot again. Okay, goes up to that root level directory, and notice the /. Okay, so if just to demonstrate once again, if I go CD space /, that takes me back as well. Okay, so if I look at this, okay, so we're talking about the bin. What was in the bin? Of course, we can't see that well, but if I bounce back and forth, bin contains all the binaries and executables. The boot directory, let's see if we find that. The boot directory is here, so that contains all, and it says it's a directory over here on the left under permissions, or under the permissions it says it's a directory. When it says it has a D in front of a particular file name, it's a directory. All of these are directories. If there's just a dash in place of this, just the D, not the DR, but just the D, it is a file. Okay, so there's boot. Looking at the next, let me scroll down, it's just off your screen. DEV, the DEV directory, they're like device drivers. Okay, so DEV, those are device drivers. Essentially, you know, they're the files that run to the drives, that run the CD, that run the screen, that do all those sort of device driver sorts of things. ETC contains configuration files that the system uses when the computer starts, the login, the password, all of those, and that's in that folder. So it would be worth quickly going to change directory and looking at all of the stuff in there. Now those are all the files in there. You can see a mixture on the left side of directory and files. Now dir, or you can type list, ls, pass. Okay, there's a file called password that contains password information. cd space dot dot. And I'm an old DOS person, so I used dir rather than list, ls, quite a lot. So you'll see me doing that continually. Okay, so we have the home directory. Let me bounce the home directory. Okay, and that contains all of our user accounts. So if we dir or change directory home, and you can see we have all of our accounts in there. These are students from this semester, from last year, so all those accounts are out there. The lib directory, which contains, I'm bouncing, there we go. The lib directory, which has the library images. And then if we start looking a little more closely at the file structure, the file system. So once again, computers use file systems to store and organize data on media, and a file system can be thought of as an index or database containing the physical location of every device or every piece of data on the hard drive. So you've probably heard Emmett talk about the FAT file on drives, especially on FAT32 or FAT16, and there's even I'm not sure, I believe it's called the FAT file, file allocation tables, what that means, on NTFS drives as well. Now let me bounce just a little. Unix is this file system that's used, let's see, which uses UFS, and also if you see it, the Berkeley Fast File System, and that's the original system. Just to be redundant, that's the original file system with Unix. And then NT file system, NTFS, so it's new technology file system, is used by Windows NT 2000, XP Vista, Windows, Server 2008, and all of those. An interesting slide about comparing FAT, NTFS, ext4, and UFS. Now, I hope, yes, that's on screen. Okay, so basically the total volume or partition sizes, some of this information is incorrect. Let's look at this. I pulled this, and with NTFS, the maximum file size in NTFS is 16 terabytes. And then the maximum volume size, which means all the files that can fit on drive C or D, for instance, could be up to 1 exabyte. Now even 16 terabytes is incredibly large itself, but that just shows you the scalability of NTFS. ext4 is the max size, again, is 16 terabytes. The max volume size is 1 exabyte. And then with UFS, and I look at this spelling here, the max file size is 32 petabytes, If we look at this picture over on the right, bottom right side, it shows us what these names are, kilobytes, megabytes, and so on, what the value is, and what the name is. And then the max volume size is 1 yottabyte. Okay, so again on the right side we have a megabyte, which is 1,000 kilobytes, a gigabyte, which is 1,000 megabytes, a terabyte, which is 1,000 gigabytes, and it's actually 1024. It's not necessarily 1,000. That's a good round number. A petabyte is 1,000 terabytes, and an exabyte, 1,000 petabytes, and a zettabyte is 1,000 exabytes, which in the yottabyte is beyond that. So it's just amazing the file sizes, how large these file sizes can actually be. So I think the last part of this is looking at inodes. And an inode is an information node, and an inode, think of that FAT file, or sort of an array, basically, an Excel spreadsheet. So an inode contains the size of a file, device ID, user ID of the file, and it's sort of that physical location on the drive that actually has and holds or references that information from. So if you can think of maybe perhaps a FAT file, and then within that there's an inode, which and that's a description for every single file and directory on the drive. I should probably have a visual for that. And the information within that inode table essentially are file sizes, permissions, and so on. So if we go back to Linux and we type in ls-i for inodes, that gives us at the root level, remember this is the root level, so the inode number 781.827 stores all of the information about this bin folder. Let me change back to home. Let's see, Scott. ls-i for inode, and we can see, and let's look at the Z's. Okay, and that gives us a little bit different view. It gives us the inode number for zoo1 is 104.4578, and that's just basically a reference number, a database number. Think of it as a primary key, if you will, and that particular database contains all the information about zoo1, and this number contains all the information about zoo2. And so that's standard throughout the entire file system. So again, think of it as a database. The inode number is a primary key that contains all the information, zoo1, where it's stored, permissions on the file, all of that. So I think part 2 will start with using path names, or path names, and prompts. So that concludes Chapter 2, Linux Chapter 2, Part 1.